I thought this was kind of a cool little snippet in the Pooh game. He goes through here and he has to check and see how many Poos are eaten. If they're all eaten, it's game over. But he does it, if you look at the Pooh .cpp file, you see that, let's see, we got, the Pooh update, okay, which actually checks, see, this updates the position of the Pooh, okay, process consumption. Okay, so this checks, to see if the dude, is near enough to Pooh. If it is, then it sets is eaten equals true for this particular object. And then this function here, the is eaten public function, will return is eaten as a status. And you can see the header here. Initially it's set to false when an object is instantiated. Let's go over to our game CPP file. What it'll do is, it has this local variable that it declares in the compose frame function. It sets it to true initially, but then it goes for I equals 0 to I is less than the number of Pooh, I plus plus. So, but basically, all eaten, is set to true to begin with. So, he basically goes through this and calls that function for every Pooh in the array, on the object array that is, and compares it to its is eaten parameter. Okay, so if any of these are false, if they're all eaten, then this will all, anding true and true, okay, would yield true. So, so in this pass, it would set it to true, and then it'll go through the loop, compare it to its last version. So if the last version was true, then, and this Pooh is, not eaten either, well, then it's true. But if it ever hits a condition where this is false, okay, then it'll and it with all eaten, and that'll turn false. So that'll set all eaten to false. So in the next loop, even if it's true, well, since this is false, well, it's going to be false, and it'll set itself to false, clear through the end of the loop. So it doesn't matter, it just has to encounter one false. And from there on out, it'll be considered false. So anyway, I thought that was kind of a clever little code snippet right there. Um, you know, this part just draws the title screen. Okay, if not is started, but if is started is true, then it basically does this little routine. And this is the compose frame, which handles the, movement and other, interactions of the characters and so forth in this part of it. It doesn't draw anything, it just handles the movement. Okay, well, this actually does. Oh, I'm sorry, though. This is, this is where the shit's drawn. It's the update model is what handles the movement. But yeah, because this is drawing the Pooh, so if not Pooh dot is eaten, it'll draw it. Okay, if it is eaten, it won't draw it. So, in theory, this is still processing a bunch of eaten Poohs, that are technically invisible, floating around on the screen because it's still having to process their data even after they're eaten. So even though it's not having to draw them, it's still having to process their position and everything. I think maybe not. It might handle that in the upper part of the code that handles the movement. Then we have our goal draw function, our do draw function, and our meter draw function, which I don't really use that meter. Then if all eaten, draw game over. So But this will draw the game over, but you can still move around and like eat goals and stuff. So this is some of the original code. This is something I was doing with arrays. Um, random device, uniform int distribution. Let's see. So it's like some leftover code here, but let's see if it's doing anything interesting or not. This is the code that draws that series of flashing squares you saw when last time I ran the game on a previous video. So it's responsible for a lot of that. I was having a bug in the other game and at the beginning of it, so I brought it over here to test it, and it turned out I just had some stupid error in it, so it was no big deal. But but still, this was kind of a cool test. Guess I could show you what it does, since I hadn't run this in this big thing. So, this thing here and this here is drawn with this code here. So, so that's kind of cool. Let me go ahead and show you what the game is. Again, I did this on a previous version. It's about going and eating shit, and if you don't die. Man, this is slow. I really got to go and change that. See, this is the goal, or the counter up there, the meter I drew. Because, for these squares that I'm trying to eat, I actually made this class all by myself. So, and again, of course, Chili, what did he do? He goes and does it totally differently than I did it. But you can see how it's updating the meter over there in the upper left-hand corner. But like I said, once you've eaten all the poo, which it doesn't keep track of, so there's no score for it. So why bother? But that's the only way to win the game. There could be poo, stationary poo behind some of these squares for all I know. Oh, well, I did it. Game over. So, anyway, cheesy little game, but still, it, was good for, learning concepts. But anyway, this is responsible for those cool color-changing squares. I'm not going to bother explaining it. You can kind of go through and see what it's doing. I mean, I'm really just going to point out in these videos like extra cool things that I learned. I'll start at the beginning of the file, so let's see, here's the constructor, for the game object, which the game object is here, and here's where it's constructed. It has several different constructors, including an overloaded operator, apparently. Let's see. Compose frame, update model. The main window instantiates that in a GFX, which GFX is the main graphics object. That's what actually interfaces to DirectX and draws the shit, and it's all technical and shit. And then we got this random number generator, which it starts at the very beginning. Uh, Instantiates a dude object. This is where all the objects that I've written, are instantiated. Or that Chili's written for the specific to this game. It's in this user variables section, I guess you'd say. Meter, old poo code, but new poos, we create an array, equal the number of poos. N poo is 30, so right now it's drawing 30. Is started as false. Anyway, if we go over to the game CPP, it's taking a lot of these objects and having to call their constructor here. And this is complicated. I still don't understand some of the nuances to how this works, because he couldn't just call it like you'd expect, and he kind of sort of explained it, but it was pretty early on, and I couldn't follow much of what he was saying on it. Like I said, this has to do with his version of the meter, I think, or the goal object or something. Okay, this looks like where he, sets up his poos, and its initial position sets them to random numbers. So, which he could have done this anywhere. He didn't really have to do it. It would have saved all this complication, because you don't actually draw the damn things until you actually start the game. Okay, and you don't want to reveal the poo until the game has started, right? So, really this did not have to be done in the constructor here. Now here was, when Chili originally introduced the random number generator thing. So he uses a different random number generator, which is kind of interesting. But it's also difficult to initialize if you want to initialize it at the beginning of your code. Especially trying to seed it and everything. I don't remember if this is seeded or not. Random device, I think it is maybe seeded. I can't remember. Okay, but then this RD thing, it was fed into this random number generator, this random device, and it supposedly randomizes it, I think. I think it's like a seed, and then you got a distribution. He's trying to generate two distributions. It's an integer, uniform integer distribution, which you also have to declare as an integer in the template here. But then you get an X distribution and a Y distribution that sets the range. So it's kind of cool, because a modulo operator, you can, like, I could certainly put like 550 and 750, just into a random number thing, like modulo 750 or modulo 570 or whatnot, and it would generate a number from 0 to 570. But with this it can generate an actual range. So doing it with modulo would be difficult, because you'd have to do it twice or some shit, and then subtract one from the other, and even then you might get some blank results. I don't know how you'd really do it, but here you can actually set a range. So I could set from like 200 to 770, for example, and have it generate a random number that falls within that range. So it's a little more versatile, and I think that's why he likes it. Originally he, in his old series, he actually used the kind of random number generator I use in the Lotto thing. So, but he's gone to this in the, since 2012. So, but anyway, that's what this originally did. This is part of some of the original code, for the Poo game, early on in his series. This is a central go loop, so we almost never mess with that. Although later on, a couple of times he does, but I'm not going to get into it. But the update model, is where we go like dude update, so this updates the position, based on keyboard input and so forth, although the keyboard capturing is handled in the dude object here. And you got to clamp the screen. Let's make sure he's on the screen and can't go off the side of the borders. Okay, this is a goal BX process consumption function. I think that it's detecting whether the dude is eating the goal, if I'm not mistaken. Okay, then this updates every poo on the board and process consumption for the dude. So, so whether the dude is eating the poo or not, it updates the goal, updates the poo and updates process consumption. I'm not sure if these should be two separate routines or not, but maybe. I don't know. It just looks like it could have done both at once instead of doing two separate function calls, and because that involves having to do calls, so it's a little bit of a penalty there. Let's see, when keyboard. Okay, this is checking to see if the return key is pressed. If it has, it starts the game. Okay, because it started defaults to false, but you can kind of see over here somewhere. It started equals false. So, and then this is a little code I add in because I like to be able to press the N key or the X key to exit the program. So, all these functions pretty much Chili defined, so they wouldn't work in general programming. Just keep that in mind. It's part of his framework. And then compose frame, we've already looked at that. And that's that draws. And this is the central loop area of the program. It'll do this. Pass through this loop at whatever the screen's refresh rate is on your computer. So, in fact, in later games, he actually introduces a variable, so it's refresh rate independent, because even this game would run at a different speed depending on what your graphics card setting is, etc. If you're doing 60 or 90 frame refresh, okay, it's going to run faster than on my monitor, for example, because I got this set to like a 30 frame, because it's run on a 4K television, and there's no real, even though I can go to a higher refresh rate, it's still just, a 4K television, worried about it, frying my graphics card as it is, so I keep the refresh rates down to half. So it's no worse than trying to run two monitors this way. Well, actually, it probably is a little worse. It's like trying to run four monitors, but but still, I do what I can to keep the refresh rate down. It seems to work fine. It doesn't bug me at all. Okay, but that's kind of just the central game loop, and then we got all these objects. So, hell. Okay, board is an object that we created. Oh hell, I don't really want to go through this, but board is an object we created. Color, he wrote most of these on screen, but I had to type them in. So, dude is an object that we created, so that's 2. Goal is an object, and I wrote this one, so that's 3. As a homework exercise. Location is a structure, and I'll show you that one real quick. This is all there is to it. There's not even a CPP file. It's just a structure, with X and Y in it. And meter, again, it's something he created, but I don't use it. But I went ahead and typed it in anyway, just to have his way available, the way he did it. So. But he implemented this whole thing inline, so there's really, there's really not a CPP file attached to this meter. So that's one of the reasons I thought I'd type it in. It's, kind of cool, I guess, that he did it that way. But then we had the poo object, That's the only other thing, other object we created specific to this game. So it does have this resource file, which is for all this put pixel calls. Um, but anyway, so basically, we got all these objects, okay, and the Poo object, we've looked at a little bit. Um, it's a class Poo. These are the public members. It's got an init function, update, process consumption, draw, graphics. So this actually draws it. And it's a constant function, so, Chili is a constant correctness fanatic, so, that you got process consumption. This is casting in a constant reference to our dude. His naming for some of these functions, I don't particularly approve of. I probably would have named, process consumption. I don't know. I don't know if that's very descriptive or not. I kind of think that could have been a better, because that kind of confuses me, honestly. I'm not really sure. Process consumption. It's, I guess, in the process of consumption is what he means by it. But anyway, I just, I think, destroy object or something like that. Object hit. I don't know. Something just a little different. But anyway, we got an is eaten. Okay, and we got a setter section, but he didn't really do any of those. So anyway, you can kind of read this, what it's talking about here. Um, but it's saying basically though that if you have getters and setters, your to the outside world, your variables look one way, right? But in the inside world, yeah, you could really change things around without having to go out and change a lot of outside code with using getters and setters as an interface. So that's one good aspect to encapsulation. Okay, initialize equals false. Static, so it's going to store this in static memory, the width and the height. So, and since all these are going to have the same, this makes it so it'll just be one copy of the variable per class. So, because in fact, one version of this would create like 1,000 Poo or more. So, 1,000 Poo objects. So, it's nice to have just everything you can, in static memory, and this never changes. So, they put it in static memory. I mean, it never changes from device to device, although you could change it, universally. But it is a constant expression, so that's saying that it'll never change. So, since it's declared static and constant expression, that means it'll never change. But if it was just static, I mean, it'd be in there and it still could change. But I'm not sure totally if it would make just one copy for the whole class, because if you didn't have constant expression, it probably still would make a separate static copy for each object. But since it's called a constant expression, that means it won't change, for any object, and it's in static memory. So, there will only be one set for all instances of the class. Is eaten equals false. But again, I think you can make a static variable though that is, global, but is also updatable. I think you can, but because sometimes, if you had like 1,000 Poo, for example, it'd be nice to have like a Poo counter or something, so that they could all say, every time you create a Poo, okay, it updates that, that static variable, every time an instance of the class is created, so it can update that, with how many Poo were created, or how many Poo have been eaten, or something like that. Boy, that would be a great application here, because then you can have a score, that, since every Poo could contribute to that, so instead of saying what their status is, if it could update that global variable, just decrement it every time one is eaten, well then fuck, you know, you would know when the game is done because that variable would be 0. So instead of having to run through like he's doing over here, you know, and you can do this with a global variable if you just want to use a global variable, by the way. But it'd still be nice to have it encapsulated by class, even though you could still access it. It's hard to access. You know, you'd have to go, you know, turn some cartwheels. You're not likely to do it by accident. Um, so, you know, but anyway, instead of having to go in and, oh, let's see, where the fuck was it? That he had, oh, we're in the wrong part of the code. Yeah, instead of having to go through each object like he did here, you know, then you just have to check that static variable, okay, and, you know, see if, you know, hey, if it's 0, well, that means the game's over, okay, you know, but you could also easily interface that to a scoreboard, you know, so I'd know how many poo are eaten at any one time, you know, that would be a simple matter then, you know, but it gets a lot more time consuming for this thing to have to, you know, 60 times a second or whatever, you know, to, you know, every frame basically it had to go through this complete array, especially if there's 1,000 poos on the board. I mean, you know, that's actually a big deal, and that starts to add up to a lot of compute cycles. So, um, so anyway, you know, it would just be nice if it didn't have to do that. You know, we just check one number and instead of having to loop, you know, because loops take time. So, um, but at any rate, you know, that's pretty much how that works. Let's see. Okay, this is an initializer. Let's see what his constructor situation was here. Um, init. I know he has a constructor. Surely he does. Well, he used to. Hmm. No, it's just an init function, you know, because I know he's having some kind of trouble and he decided to go just do it this way. So yeah, I don't think there is a constructor here. You know, it's using constant, you know, constant function. And oh, and that caching thing too. I mean, it's actually pretty clear if you look at it. You know, oh, here's this no. Well, see, this isn't even a constructor. So, okay, well that's having a graphics object passed into it. Um, you know, when you pass the draw, you got to pass GFX into it. Most of his code's like that. So never mind, we'll get to it later. Most of it's poo and travel restrictions. So, you know, this is what updates, you know, the poo's motion. Process consumption is him getting eaten, or it getting eaten. And is eaten is our function that we looked at earlier. So width and height, these are its location variables. I guess he hadn't updated this to that location structure yet, because that's rather natural to use that. And he, you know, develops that concept further in other games. Is eaten equals false. Okay. Let's see. Which original code here, because this is his original constructor. So in it. Okay, yeah, he's using the assert here, you know, so let's see how that works. It's just for debug mode only. And here's where the update is. You know, we're working Vx and Vy are the velocity, so, you know, it's updating the velocity. checking for screen collisions right here, you know, with the border. Process consumption, this is checking for collision, basically, with the dude, so see if he's eating it. Passed in dude object as a constant, so it creates a temporary, you know, instance of dude here. He's passing in a reference to it, really. So this is, you know, just checking to see if there's any overlapping in the coordinates, and if there are, well, he is equals true. And then process consumption. So it's pretty much as simple as that. Okay, then let's look at this board object. Where is that drawn at? Board. Let's see. Goal box, okay. Draw game is over. It has to be drawn every time. If it's going to be on here, it's going to be drawn every time. Let's look at game H. Dude. Yeah, board. There is a board object. So, where is it used? It might just be used for collision detection or something. I don't know. Yeah. Well, I don't know. Update model. Dude. Where's the board being drawn? Meter.draw, dude.draw, goal.draw, poo.draw. Huh. Where the fuck is the board drawn at? Down there. Ugh. Huh. I don't know. Maybe it's not used. I mean, surely it's not here. It's board GFX. Okay, well, what's the fucking thing do? Okay, now this is talking about an interesting fact that, you know, if you have like a header file, okay, and you start to define these classes, you'll notice a little light bulb pops up, and one of the options is being able to promote it to the document. But if you don't already have a CPP file, it'll actually create one for you and actually, you know, copy this to that CPP file. But if you do have one, it'll just, you know, you can promote it to document, and it'll, you know, actually copy it in there, you know, with all this stuff set up for you. So you just have to start filling in the code. Draw cell. Oh, actually, I know what this is for. Okay, yeah, that's confused. It's not actually part of the Poo game. That's actually part of, you know, actually just look, you know, we actually look, just went right over it. It's, I thought it was part of the Poo game, but it's actually not. It's part of this down here. You know, see, board object. So that's, you know, again, part of that, those colorful squares. So that's what that is. I guess we should have looked at that more closely. Now this is his meter implementation. Like I said, I don't use it, so it's not actually drawn in the game. You know, but this is all, you know, he just implemented it all in the header file here. So, but my version of this is this is the the object that, or the class that I made, and I made this part of, you know as part of the homework. It's one of the few homework assignments I decided to go ahead and do, because I was starting to get frustrated with not being too afraid to do anything, because I was afraid he'd do it so differently that I had to retype everything. So anyway, but it was pretty simple because this stuff was already defined inline, and as part of introducing classes, that's one of the things we did, is take all the code that we had in the game.cpp file and put it in a class. So, it wasn't that difficult, and, I followed some of his naming conventions when I did it just to be consistent. But he, of course, ended up doing it quite a bit differently than I did, but I still just stuck with my version. I said, fuck it. This is getting old. Because of course he's going to do it a lot differently than I did. But at any rate, we got constant expression, for integers and stuff like this. And most of this I think I copied out of the CP, or the game.h file. So anyway, we got width, height, ticket number, etc. And these are all constant. So, and we can do this because this is just for the dude, but these actually specify the dude's height and width. So when we're using put pixel calls, it'll draw it using that information. And we got tick width and tick height, which are part of my menu, my graphic menu, which I guess I drew, and tick X and tick Y, other features of it, other parameters. Times eaten equals 0. Void random lock. And he actually changed the game. I mean, he changed it so if you hit the poo, it kills you. But I just left it like this because I was rather fond of it. So, I just didn't feel like going through that part of the process. So, at any rate, these are the functions we have. We have a goal constructor, but it's pretty much a default. I should have said equals default like he does. Void draw graphics in GFX. So, so that's a function for taking care of that shit. And we got process consumption, so that's the process of eating the squares, I think. I don't know. Times eaten, okay. Times what eaten? Oh, the goal. Okay, yeah. No, this is for the goal. Okay, I'm lost. We haven't covered the dude yet. So, anyway, but if we go look at the goals CPP file, originally I was trying to, as part of my constructor, I was trying to create, I don't know, some kind of random device, because these goals need to appear randomly, right? But I just went in and decided to, as part of my constructor, said fuck all this because I was having some difficulty, but I wasn't done with it yet. And I decided just to create a random function that you can call at any time. And it just basically sets all this up like a, kind of like you saw in the original code over in the game CPP constructor. So it's pretty much an identical copy of it, just with some slightly adjusted parameters, but it creates that initial random position, but you can call this throughout the lifespan of the object. So, it calls it right at the beginning just to kind of initialize the random seed or whatever, and but then you can call it over and over and over again. So, draw, here's a draw function, which, let's see, PV equals 1. Okay, so these are color settings. So, this is why I actually cycle through the different colors on the square. That's why it's fading, and this is kind of my little special effect for that. And I went ahead and made my own. Like I said, I could have used the draw rectangle function I did in the graphics.cpp file, but I decided to go ahead and just do it like this for shits and giggles, because honestly, I forgot about it. I forgot that it was even there. Um, get color equals get color plus 5. So anyway, it just cycles through colors, is what it does. So it's, and there's a process consumption, which tests if, we're overlapping with the square, and then if so, well, guess what? Times eaten is incremented, and random location is called again, and C band is incremented. I don't know what C band does. C band is greater to 2, the C band equals 0. So I know it's color band. See, C band. So that affects my little color algorithm is what it does. So again, that's the process of it being eaten. Just increments times eaten, and basically increments are a little goal or scoreboard. So, and this returns times eaten. And this draws the graph right here too, by the way. This draws a square, but this is what actually draws our little graph. So, times eaten, is what it's predicated upon. Tick width times eaten. So, that's what keeps track of our score. So, since we don't have the ability to frickin' draw text in the fucking game, but at any rate, so that's the little module I did, and then the only other thing to cover is the dude .h and dude CPP file, which draws the main character. So here's the dude .h, clamp to screen. Okay, get X, get Y, get width, get height. These have to do with, collision detection and so forth, I think. And the clamp to screen. So this is what, again, keeps us from going off into the ether and generating an error. Draw graphics in GFX. This is bench put pixel statements. So, which is the only way to actually draw on this thing, actually, is with a put pixel statement. It's really the only graphics method, the only basic graphics method we actually have in this is that put pixel statement that Chili provided. We got update. Keyboard is pressed. This is where we accept keyboard input. This is the update command. So we're looking for the right arrow, left arrow, up arrow, down arrow, and it updates the dude's speed, based on that. Then we got get X, get Y, which just returns the X and Y members. So that's a getter method. And this is also another getter method, for hit width and height. It's really pretty straightforward, really quite simple. So, that's pretty much it. That's pretty much it to this program. So that's all it does. It's, again, my first real exposure to classes. And what's nice about Chili, and this is what I really like about a series, is that before Chili, just reading this shit in books about OOP and classes, again, you saw You know, if you looked at any of the videos in the series, you saw what kind of fucking bullshit, ridiculous examples they have for using classes. You're like, why the fuck am I bothering learning this crap? And how would I ever use this shit? Like I said, it's like learning algebra in high school. You know, nobody has a damn clue what good any of that shit is. But you know, with Chili, okay, now I understand. You know, I can see the point to classes. You know, video games, objects. Okay, it's all gluing together, and you can see it for the first time in my life. I actually understand the utility of objects thanks to Chili, and that's what Chili did for me. So, see what Chili can do for you. Anyway, and I don't mind giving him a bump, you know, over at planetchili.com, and he's on the YouTube. Let's see. I know I got some of the stuff up here. Yeah, well, here's one of his deals. So, DirectX Programming Lesson 7 is Chili Tomato Noodle, so on YouTube. So, um, and this is his old series too, by the way, so, you know, which I was looking for. So anyway, but yeah, definitely check it out. It's got some good shit, you know, that he does. Especially as his series, you know, this guy really knows his shit. I mean, he's good. You know, again, I just pull my hair out sometimes, you know, at the pace, because a lot of this shit, I do actually have experience with coding, you know, and he's made this for people with no experience coding whatsoever. So, anyway,